All right, let's try this example number 2. It says a ball is thrown from a height of 1 meter. At the time of release, the velocity of the ball is given by 27.2 I plus 12.7 J. Notice that's your horizontal I and vertical J, okay? Where each component is given in meters per second, find the initial velocity V sub 0 or V naught and the angle theta above the horizontal in degrees at which the ball was thrown. Okay, so we just saw a couple of things, and one is that the magnitude of the vector is a squared plus b squared, and that's going to be v naught. So v naught is the square root of 27.2 squared plus 12.7 squared. And notice this is going to be calculator work, right? That'll be 27.2 squared. And then 12.7 squared. And when I add those, that's the square root of 901.13. And if I take the square root, that's about 30, 0.0188. If I round to 0.0182, etc. Okay, if I round to 1 decimal place, so the velocity is going to be about 30. And these are meters per second. Okay, so that was one question. And the second one, what is the angle theta? Remember, tangent theta equals b over a. Okay, so here, and notice this is 27.2, the horizontal. I can actually draw that. 27.2 that way and 12.7 that way. So there's your velocity there. And these are the component vectors, horizontal 27.2 and vertical 12.7. Those are their magnitudes, right? Their magnitudes. The magnitude of the horizontal, magnitude vertical, and the magnitude of the actual velocity, which was 30. All right. So so notice this angle theta, right? Is the tangent of theta is b over a, opposite over adjacent. That makes a lot of sense, right? If you think of it that way. Alright, so here tangent theta then is going to be 12.7 over 27.2, and if we take tangent inverse, theta is tangent inverse of 12.7 over 27.2. And notice I'm using tangent inverse, but that remember, tangent inverse gives us one answer. The way we know which answer to pick is we know where the vector is. It's in quadrant 1. Okay, so tangent is going to be an angle between 0 and 90. Okay, so 12.7 divided by 27.2, tangent inverse, and I get 25 degrees. So theta is about, it's actually 25 point something, 25. This is round to nearest to 1 decimal place. So this one was 30 point, the velocity was 30.0 rounded to 1 decimal place, and the theta is 25.0. It's 25.028, etc. So if I round it to 1 decimal place, it's 25.0 degrees. Okay? All right. I'm going to leave the next example for class. It's a good example because we use right triangles, and we can use what we know already about right triangles. All right. And let's try this other example. It says the magnitude of F1 is 32 pounds. The magnitude of F2, there's F2 and F3. So F2 is 24 pounds and the magnitude of F3 is 15 pounds. Write the resultant force R in terms of I and J. Okay, so what I'm going to do is I'm going to find each of these in terms of I and J. So F1, notice, only has a vertical component, which is J. So F1, and the magnitude is 32, F1 is 32J. It's actually 0I, right? 0I plus 32J. All right, how do I find the components for F2? Well, F2 is 6. What's the magnitude of F2? 24. 24 times the cosine of theta, and remember theta is this theta right here, right? From the positive x-axis. So let's double check to make sure. It is indeed. All right. So from the positive x-axis, so this is 90 plus 68, that's 158. So this is going to be, what was the magnitude again? I forgot. 24, let's write the magnitude here. 24, and the magnitude this way is 15 for F3. All right, so this is 24 cosine of 158 I. So 158, let's make sure our calculator's in degrees. It is 158 cosine times 24. And that's negative 22.3 I. Okay. And then 158, sorry about that, not 60, 158 sine of 158 times 24 is 8.99, so it'll be about 9.0 J. Okay. All right. I'm going to do the same thing with F3. So the angle is 320, right, from 0 to 360. So 320, and I take the cosine and multiply times 15. That's 11.49, etc. So it's 11.5 I. So this is 11.5, F3 is 11.5 I. And then J is 320 sine times 15, negative minus 9.6 J. Okay, and then to find the sum, I'm just going to add all of those component-wise. So I'm going to add all the A's. This one doesn't has the A is 0, right? You can think of 0I plus 32J. So the A's, just these two have A's, right? Negative 22.3 plus 11.5. So the resultant is going to be, well, let's write it here. So let's write that we're going to add 0I plus 32J. 0I plus 32J. And then F2 is minus 22.3I plus 9.0J. And then F3 is 11.5I minus 9.6J. And all we're going to do is just add them. Okay? The A's and the B's. And notice that we want our answer in terms of I and J, and we'll have it in terms of I and J. So minus 22.3 plus 11.5. That's 22.3 minus 11.3. 10.8. So minus 10.8 I. And then 32 plus 9 minus 9.6, that's 31.4 positive plus 31.4 J. And that's my answer. Negative 10.8 I plus 31.4 J. So it's going to be somewhere in that direction, going more or less that way. And notice that these two are pulling up, so the resultant should be up that way. All right, so that's R, right? We were calling it R. So the vector R is negative 10.8 I plus 31.4 J. All right, and we're going to leave this, I think this is the last example. Yep, we're going to leave this last example C for class. Okay, so we're going to say this is the end of the second part of 8.4.